Arc Addition Postulate on page 356. We're going to continue on with question 2 and 3 and 4 and 5 on the next page, as far as we go. Now, in this one, we've already answered or addressed the angles in the clock from A to B and B to C. So go back and watch a video if you haven't yet. Make your note card for Arc Addition Postulate. But let's go ahead and talk about considering circle O. Question 2. Plot and label point D on the circle so that it corresponds to the number 7, right? Here's the full instructions for a second. That it corresponds to the number 7 on the clock, and then use the arc addition postulate to determine the measure of arc BD. Okay, so that's the goal. So I'm going to go back up to here. I'm going to put a number 7 on the circle and a D, point D right here. And I'm going to highlight it up, right? I need some highlight color in here. So DC goes from hour 6 to hour 7, right? Hour 6 to hour 7, there it is. And then BC goes from hour 2 to hour 6. What we've learned in the last video that each of these skips are 360 divided by 12, 30 degrees. So therefore, 30 plus 30 plus 30 plus 30 plus 30, right? Enough 30s to go 5 times. That tells us how big the arc BD is. But I'm going to acknowledge I want to use this structure here, okay? So I want to show the math sentence, do the substitution, come up with an answer. So first of all, because we're going from point B to point D, that entire arc, the smaller amount, it's going to pass through a point C. So I want to know the measure of arc BC, and I'm going to add to that the measure of arc CD. All told, that will be the angle degrees. That'll be the measure of the degrees of arc BD because of arc addition postulate. So if I remember back, I looked at that, I said that BC as a measurement goes 30 plus 30 plus 30 plus 30 degrees. That's 120 degrees. 6 to 7, the other arc is 30 degrees. So I can use those numbers to substitute into my equation. 120 degrees is the measure of arc BC, and 30 degrees is the measure of arc CD. So when I add them together, 120 plus 30, mental math, think about it in terms of money. If you don't know right away, $120 plus $30, I don't want to lose out on any money. I better know how to add them together. It's 150. That's the measure of arc BD. Seriously, if you can't mental math money, you're screwed. So practice your mental math for money so you don't get caught up in that noise. Now, at which numbers on the clock could you plot point E, right? We want a point E that lets us know arc BD is the same as arc AE. And I'm going to kind of cheese it because I know that how many hours there are between these 2 points. There's 1, 2, 3, 4, 5. So in order for me to figure out arc AE that has 5 hours in it, I'm just going to count up. 1, 2, 3, 4, 5. Put point E on the 3. Because to go from point A all the way around to point E, you're going to pass through 5 hours, which is also 150 degrees. 30 times 5. The measure of arc AE equals the measure of arc AB plus the measure of arc BE, which is 120 plus 30, which equals 150. That's how I know. I added them up. There is another place you could put it at the 5 o'clock, right? We could go counterclockwise. We could go around like, this way, and it would still work. So 1, 2, 3, 4, 5 o'clock. This is a potential E location. I just didn't choose it, but maybe you did. Cool. All right. Next up in our list, we have if the measures of 2 central angles of the same circle or congruent circles are equal, what are their corresponding, are their corresponding minor arcs congruent? If the measures of 2 central angles of the same circle or congruent circles are equal, are their corresponding minor arcs congruent? Think about it. Yes, they are. Right? We have that example in number 1. Like number 1. So that's what's happening over here on this question. Like number 1, the central angle says how far open the arc should be. So all central angles that are the same, like opening, they're all equal. And because those central angles that all have the same opening are congruent, the arcs that they create are congruent. If the measures of two minor arcs are the same length, right, of the same circle are equal, are the corresponding central angles equal? And yes, for the same reasons. Yes, like number 3, right? So if you know that, like, from A to B is 120 degrees, this arc is 120 degrees, and B to C is also 120 degrees, well, then the central angles that create them, these right here in the middle, those are matching, right? Now, like number 3 and number 1, if arcs are congruent, then the central angles that create those arcs must be congruent. Okay, last one. Alicia explains to her classmate that SC is congruent to TX. So how did Alicia arrive at this conclusion, right? Is Alicia correct? Well, here's the difference, right? The measure, and what's the notation I need to use? The measure of SC is equal to the measure of TX. That's true. The degrees are equal. And so if they're going to be equal in angle measure, cool. But the thing is, these circles are not congruent, right? But circle, what's the notation here? The circle SC around O is not congruent to circle TX around O. Right? They're not the same size. So if the circles are not the same size, then we're not able to actually say that arcs that have the same measure are actually equal in length. So there's a difference here. Congruence means same size, same angle, perfectly like equally matching. And I mean, just by like tracing it, like SC is not as long as TX. It's all because the circles are not congruent themselves. All right, so same angle measure, for sure. The degrees are the same. However, the arc lengths are not the same. We'll get into more detail on that one as we go on. Thank you for watching this video. Keep going. Like, comment, and subscribe. See you later.